Hello guys, welcome to today's video. In today's video, we are going to learn about absolute value function. Okay, so sometimes it may be called as modulus function. Okay, modulus function. Okay, so whatever you hear modulus function or absolute value function, the meaning is the same. Okay, so don't worry if you don't worry if you see modulus function in some questions. Okay, so the meaning is the same. So if they ask about modulus function, it means they are talking about absolute value function. Okay, now first of all, let's come to the definition point of view. What is absolute value function? Okay, so let's take a number line. Okay, this is our number line. Okay, here I have 0. On this side I have positive integer plus 3 plus 4 plus 5, so on up to plus infinity. Okay, and here on the left I have negative minus 2 minus 3 minus 4 minus 5, so on up to minus infinity. Okay, so the absolute value function or the modulus function, it represents the distance of the point from the center. Okay, for example, what does it mean? For example, if my point, let's say that my point is here. Okay, let's say that my point is here. Okay, so the absolute value function is going to be this distance, which is going to be 3, right? And it may happen that my point is on the left side of the region. Then in that case, there is no problem. Okay, for example, if my point is here, minus 2, right? So if I have to find the absolute value function of this point, so I have to find the distance of this point from the origin. Okay, so this point is 2 units away from the origin, so its absolute value function of this point is going to be 2. Okay, so from here we can see one thing: the absolute value function is always going to be positive. Okay, so absolute value function, it is represented by vertical bars. Sometimes we call it vertical pipes or parallel pipes. Sometimes people, they call it it's a symbol of absolute value function, and they call it vertical bars. Okay, so you can call it vertical bars. The meaning is the same. It represents the symbol of absolute value function. Okay, so the beauty of this symbol is, the symbol of absolute value function is that if you are going to put any negative number in it, the value is going to be positive. For example, negative 3, so the absolute value function of negative 3 is 3. Okay, if you put here any positive number, of course the value is going to be positive. Okay, so it's like a punch bag. If you throw in some negative number inside this punch bag or within this bars, then it's going to punch that negative number so hard until it says that, oh, I'm no longer a negative person. From now on, I'm positive. So once it says I'm positive, the number will just pop out and you will get absolute value function. Okay, so we can summarize, see here, we can summarize this whole thing as, okay, so can I write, okay, so can I write this is absolute value function, this is absolute value function x, okay, so can I write x is the absolute value function of x is going to be positive x if x is greater than equal to 0, okay, and minus x if x is less than 0. Okay, see here, you can take any case. If you can take any negative number, for example minus 2, okay, so the absolute value function of minus 2 would be minus of minus 2, which is going to be positive 2, which is going to be positive 2. Okay, I hope it made sense to you. Okay, sometimes some students they get confused that, oh, why are you writing here minus x, it should be positive x. Look here, x is negative, so negative of negative x is going to be positive x. Okay, so take note of this point. Okay, so I hope this is clear to you. Okay, then we have one apparent absolute value function. Okay, y equal to modulus of x. This function is very, very important. Okay, this parent function is very, very important because later on, whenever we are going to do an equation on absolute value function or modulus, this parent value function is going to help us a lot. Okay, so this is your parent value function. Okay, parent value function, you can also call it parent absolute value function. Okay, this is the base. Okay, so it's the same thing, y is equal to x. Okay, y is equal to x if x is greater than 0, or y is equal to minus of x if x is less than 0, if x is a negative number. So negative will get cancelled out, and in the end the positive number is going to stay. Okay, then here we can discuss the domain. Okay, domain of this parent function. D for domain. Domain means the input. Okay, so this is our parent value function. So what's going to be the domain, or what numbers can you put inside, or can you put within these vertical bars, right? So here you can put any number. You can put positive integers. Okay, for example, see here, this is my number line. Okay, here I have 0, on this side positive 4, here negative -2, -3, -4, so on. Okay, so I can put any positive integer, right? Or I can put any negative integer. So I can say that I can put any real number, right? So the domain is going to be minus infinity to plus infinity. Okay, I hope you got it. Okay, now let's discuss about the range of the function. Okay, range of the function. range of the function. So domain means the input. Okay, here I'm writing, it means input, or you can also call it values of x. Values of x. It can take positive value, it can take negative value. So domain means input. Okay, and range means output. What's going to be the value of y when you put any number from your domain here? Okay, so see here, these positive integers and 0. Okay, so whenever you have these as the input, your output is going to be positive, right? Positive. And when you have negative integers as the input, still the output is going to be positive. Okay, for example, uh, absolute value function of -2 is 2. See here, 2. So I said, even if my input is negative, but still I'm going to get the positive output, right? So can I say my range is from 0, because this means 0 included. Okay, this is a bracket of inclusion. Okay, so 0 included to infinity. Okay, because when you put any negative integer in the modulus function, then it pops out as positive. Okay, so range, I would say here, is 0 to infinity, positive infinity, positive infinity, positive infinity. Okay, I hope it is clear to you. Okay, sometimes they may ask you about the domain and range, so it can take any real number as a domain, but output is always going to be positive. Okay, such a great function, always be positive. Okay, now let's do one question, simple question. Okay, we'll start with simple question. This is very interesting topic, so we'll start with simple question, and then later we are going to sketch the graphs for modulus function. We are going to sketch the inequalities. Okay, but we'll do that later. Let's start with basic. Okay, my first question to you is, okay, I can write here. Okay, my first question is, modulus function of x is 5, find x. Okay, modulus function of x is 5, find x. Okay, now see here, uh, modulus x, right? Modulus x is equal to 5. Okay, so what does it mean? It means either my input is 5, then it's going to happen, or my input is -5. Understand? Yes or no? Okay, so you will get mod x equal to 5 only when your input, only when, see here, when I can write here, only when your x is 5 or or minus 5. Okay, when it is x or minus x, right? So what's going to be the x? So x is going to be 5 or minus 5. Okay, I hope you understand it. Now see here, so the modulus function of uh, any variable here, it would be 5 when your input is 5 or your input is minus 5. So that's what I did, right? I hope it made sense. Okay, then there is one more question. X minus 5, the absolute function of x minus 5 is 3, and you have to find x. Now see here, this is a good question to practice. Okay, now the modulus of this is 3. Okay, it can only happen if your input is x or minus x, right? So what does it mean? It means if your input is going to be 3 or your input is going to be minus 3. Okay, only in that case you will get 3 as the value of your absolute function or modulus function, right? So the input would be 3 or minus 3. Okay, from here the value of x is going to be 8, and from here the value of x is going to be 2, positive. I hope it made sense to you, right? Okay, let's take few more questions. Let's take few more questions. My next question is, if x is less than 3, if modulus of x is less than 3, find x. Okay, so you are given that the modulus of x is less than 3, you have to find x. Okay, so now what you can do is, the best way to visualize is to draw the number line. Okay, so in math, number line is very, very important. This is positive 1, positive 2, 3, 4, 5, positive infinity this side, negative 2, negative 3, negative 4, negative 5, negative 6, negative infinity. I hope you understand this. Now it says that the modulus function of x is less than 3. Right? Now see here, it's less than 3. Now see here, here I have positive 3. Okay, the modulus function of positive 3 is 3. But here the condition says that if mod x is less than 3, it means I am not going to include this point 3. Okay, 3 is not going to be included in my domain. What I'm doing, I'm finding domain. Okay, I'm finding domain and I'm given the range. It says that modulus of x is less than 3. So here I'm not going to include 3. So I put cross on 3. Okay, now if you see on the right side, as we increase the input by 1 unit, so the modulus of these numbers is going to be greater than 3. It means I don't need these inputs. Understand why? Because if I will take these numbers greater than 3 or 3 as my input, then the absolute value function is going to be 3 or greater than 3. Okay, now let's take the other case. Now from 3 come to 3 is not included. Okay, so now come to this 2. If I take 2 plus 2, 2, yes, it's less than 3. Yes, so it will come. Yes, this will come 2. This will come 2. This 0, yeah, here, minus 1. Now see here, minus 1, the absolute value is 1, right? So it's less than 3. Then minus 2, yes. Now minus 3, modulus function of minus 3 is 3, but it says less than 3. So this 3 is not going to be the part of it. Means just less than 3. Okay, so it's going to be from here to here. Okay, and all these inputs will be rejected, because when you put these as inputs, your absolute value function is going to be greater than 3, which is not needed. Okay, so your x will be, so x belongs to minus 3 to 3. Okay, now see here, this is a bracket of exclusion. Okay, means that everything between minus 3 to 3, but minus 3 and 3 not included. Okay, and this is the bracket of inclusion. Okay, if I put this bracket here, close bracket, it means that yes, this minus 3 is the part of the domain. Okay, so here, this one. I hope you understand the logic. Okay, now take one more question here. The next is question number 4 says that if modulus function of x is greater than equal to 2, find x. Okay, again, we will use what? Number line. Okay, number line. Okay, this is 0. I will use black ink for this. Plus 1, plus 2, plus 3, plus 4, plus 5. On this side, negatives. Minus 3, minus 4, minus 5, minus 5, minus infinity this side, positive infinity this side. Now see here, the question says if modulus function of x is greater than equal to 2. Okay, so greater than equal to 2. Now come to this positive 2. The modulus function of this positive 2 is 2. It means it is going to be part of the domain, right? Why? Because modulus function must be greater than equal to 2. Okay, as you go towards the right of positive 2, positive 3, it's 3, greater than 2. So if you take modulus function of all these numbers on the right of 2, including 2, it's going to satisfy this condition. Okay? Now, 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 come to the towards the left of 2. If you see here, this region marked with red, if you see here the absolute value function, for example, here positive 1, so it's going to be 1, okay, which is less than 2, so it's not going to be the part of the domain. 0, no. Uh, -1, the absolute value function is 1, and it won't be the part of the domain. Why? Because the range says greater than equal to 2. -2, now see here, for -2, see here, for this -2, it's 2. So it satisfies modulus of x greater than equal to 2. So it's going to be the part. And as you move towards the more left of -2, all these numbers are going to be the part of the domain. If you take the modulus function of -3, it's going to be +3, satisfies. -4, 4 satisfies. -5, 5 satisfies. So what's going to be the domain? So from here, can I say, from this side, can I say -infinity to -2, and here I'm going to put closed bracket, inclusion, right? -2 is included, and on this side 2 to infinity. Okay, so it's going to be the union of this. So your x is going to be this, or in short, okay, if you don't want to write like this, you can also write, you can write, if you don't want, if you think this is complex, it's not complex. See here, it means that less than equal to -2, and this one is greater than equal to +2. So you can also write x, it means less than equal to -2 and greater than equal to 2. Or you can also write -2 x 2. No. Yes. Okay, so these all are your domains. Okay, so I hope these are just easy questions. Okay, you can just draw the number lines and you can check your what is the condition placed on the absolute value function, and then you can just play with the domain and you can easily get the domains. Okay, now next is important thing, but before we do that, I would like to discuss something. Okay, so okay, so before, when we started this, in between, I have told you that y equal to modulus of x. This is absolute parent value function. Okay, because this is a parent function, because anything that we are going to do, we are going to put this as the base of everything. Okay, this is very, very important. Okay, now see here, and you know what does it mean? It means y is equal to x if x greater than equal to 0, and negative x if x is 0. Okay, so that's what it says. Okay, now if I have to draw the graph of this parent value function, okay, this is 0, 1, 2, 3, 4, 5, negative 1, 2, 3, 4, 1, 2, 3, 4, negative 1, 2, 3, 4, so on. Okay, this is your x axis, this is your y axis. Okay, so if you draw the graph of y equal to x, see here, what does it mean? When you put when when you put x1, y is going to be 1, x2, y 2, this one 3, this one 4, y 4, this one. So in the end, when you are going to trace the points, you will get something like this. Okay, so this is going to be y equal to x, right? Y equal to x. And what is the graph for y equal to minus x? Okay, now see here, when you put when you put minus 1, then minus of minus 1 will be 1. So minus 1, 1 here. Minus 2, y is going to be 2, means here. Minus 3, 3 means here. Minus 4, 4 means here. So what you will get is this. This, okay? So this V-shaped graph, okay? This V-shaped graph. Now this is for y equal to minus x, okay? So now this V-shaped graph, is the graph of y equal to this V-shaped graph is the graph of absolute parent value function y equals mod x. Okay, see here, very simple. This one, y equal to x, y equal negative x. Okay, if you are going to put 0 or positive values, you will get positive values of y. See here, y is positive. Okay, and the other says that if you put negative values, negative inputs of x, then you will get the positive values of y. So that's why it's a graph of absolute parent value function. Okay, now we will analyze few things here in this graph, which is going to be very, very important. You must know these things. If you don't know these things, then later on it's going to be the problem. Okay, now the analysis part starts here. Okay, analysis part starts from here. We are going to analyze this graph. Okay, now this y equals x, y equal negative x. Okay, let me write this: y equal to x, y equal negative x. These all are the equations of the straight line. Okay, both these equations are the equations of the straight line. Okay, see here, I can write here equation of straight line. Okay, equation of straight line. The general equation of straight line is y equals mx plus c. Okay, we have to understand this. If you don't understand this, later you will get the problems, because in parent value function, we are using y equal to x, y equal negative x. So the v-shaped graph, it's formed by two lines. Okay, and this is the vertex. Okay, so we have to understand it. Okay, so the equation of line, this is general equation of line, general equation of straight line. Now see here, this m means slope and this c means y-intercept. Now, because here the slope is 0, sorry, here the y-intercept is 0, right? That's why it became y equal to x. Okay, if it has some positive or negative values, then that positive or negative value is going to be the y-intercept. What does it mean? Now, let's see. Y equal to x. For y equal to x, the graph is this. Okay, if I have to make a graph of y equal to x minus 1, what does it mean? This is y-intercept, means minus 1, y-intercept. So the graph is going to be this. If I have to draw a graph of y equal to x plus 1, okay, for x plus 1, it would be this is positive 1. So this is going to be the y-intercept. So it will pass through 1. It will pass through 1 here. It will pass through negative 1. Okay, so this here is the y-intercept. This is very, very important, because later on we are going to use transformation, and when we will shift the abscissa and the y coordinate, then you will see, you will get the problem if you don't understand this. Okay, then the next is, this is slope. Okay, I hope you understand y-intercept. It's simple. So if it is positive, then your your graph will pass through the y-axis at that point. Okay, if it is negative, then your graph will just pass through the y-axis at that point. Okay, now next is your slope. Next is your slope. Now, this slope, what does it mean? Slope m or slope means rate of change of y with respect to x. Now see here, for example, here, okay, here, uh, this is my point, okay, this is my point 2, 2, okay, the coordinate is 2, 2, and this point, the coordinate is 3, 3, okay. So what does slope means? Slope, now see here, slope means from this point to this point, what's the rate of changing of y with respect to x. Now see here, this point, the y coordinate, was 2, right? Here the y coordinate is 2, and here the y coordinate is 3. Here the x coordinate is 2. Here the x coordinate is 3. So I can say that the rate of change of y with respect to x is 1. What does it mean? It means as you go one as you go 1 unit, to the right side, then then you are also going 1 unit up, okay. So then it means 1, right? Your slope is 1, okay. Now see here, when your slope is 2, what would happen? Y equal to 2x. You put here, now see here, y equal to 2x. I can draw here, y equal to 2x, okay. Y equal to 2x. Y equal to 2x. Slope is 2. What does it mean? It means 1, 2, 3, 4. Here -1, -2, -3. Here 1, 2, 3, 4. Now see here, if I put value of x1, then y is 2. What does it mean? I'm taking one step towards right, then it's 2 steps up, okay. It means y is changing twice as faster than 1. Understand, here the rate of change of y with respect to x is 1 unit, x1 y1. Here the rate of change of y is double than x. I hope it made sense to you, okay. So if these things are clear to you, then we can do few more analyses here. First analysis is shape of your 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 uh, your modulus function graphs, okay. Shape, okay. I can erase it because I need some space. Okay, I need some space. So now let's come to the shape. Now I have said that this m is slope, and it will also tell us the shape, okay. If now see here, if your slope is positive, then your graph will open up, okay. It will open in upward direction like this way, okay. But if your slope is negative, for example, y equal to minus x, y equal to minus x. Okay, y equal to this is the graph of y equal to modulus of x. So if you make the graph of y equal to negative mod x, then your graph is going to be something like this. Okay, this is y equal to negative mod x. Why? Because your slope is negative. Okay, your slope is negative. Okay, for example, when we draw any straight line, okay, y equal to x or y equal to x plus 1, here slope is positive, right? Here slope is positive, so positive slopes always goes like up. Okay, but if it is x minus 1, then your graph, it will be like this, downward. Okay, so same here, if your slope is positive, okay, or if you can say that if the value outside the modulus function is positive, then your graph will open upward. But if the value outside your modulus function is negative, then your graph will open downward. I hope this is clear to you. Okay, so first is shape. If 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 for example, here I can write y equal to a modulus x, right? If a is positive, then graph will be opening upwards. If a is negative, opening downwards. Okay, here this is going to be the reflection of this around horizontal axis, right? So I hope this is clear to you. Okay, now let's find it out. Let's find few more interesting observations. Now here I'm saying y is equal to a modulus of x. Now I am writing the way a can be 1, 2, 3, so on. So here y is mod x, y equal to 2 mod x, and y equal to 3 modulus function of x. Okay, now I want to draw the graphs of this. I want to draw the graph of this here. 1, 2, 3, 4, 5, 6, minus 1, minus 2, minus 3, minus 4, minus 5. Here 1, 2, 3, 4, 5, 5. Here minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, so on. Okay, this is x-axis, this is y-axis. Okay, so I hope it made sense. Now see here, y equal to mod x, y equal to modulus function x. Now here the slope is 1, means that if you go 1 unit towards your right, so you have to go 1 unit up. So it's going to be like this, like this, like this, like this. So this side, this, and this side, it's just going to be the mirror image. Mirror image, minus 1, 1, minus 2 here, minus 3, 3, this one minus 4, this one minus 5, this one. So it's going to be like this, okay, like this, okay. So minus 4, minus 3, 3, somewhere here, here 2, somewhere here 1, okay, something like this, okay. So this is y equal to absolute x. Now here I have changed, sorry, here the slope is 2. Slope is 2 means that y is changing twice as faster as x. Means if you take one step towards your right, y will go twice units up, right? So it means for 1, y is going to be 2. For 2, y is going to be 4. For 3, y is going to be 6, somewhere here, okay? So if you join these points, okay, uh, let me use different marker, okay? If you are going to join these points, it's going to be like this. Okay, and here the same, minus 1, 2, minus 2, minus 2, 4 here, okay, here. So see here, this is y equal to, the blue one is y equal to modulus function x, and the black one is y equal to 2 times modulus function x. Now as as the value of a increases, as the value of this slope increases, you can see this graph will become more narrow, or I can say that this graph is going to get compressed, right? See here, y equal to modulus function x, it's same like v, but 2 times modulus function x, it become more narrow, right? So if you will do it for 3 times x, now see here, if you take 1 towards your 3, then this is going to be 3, next 2, 6, so it will get narrower, okay. So this is going to be for y equal to 3 times absolute value function x, or modulus function x. So 3 times 2, see here, I can say, okay, see here, this was for modulus function x, 2 times modulus function x, so it will get more narrow, okay. So 3 times it will get more compressed. So as the value of a increases, okay, as the value of a increases, what happened? As the value of a increases, you can write here, as the value of a increases where a is greater than 0, the curves get compressed. So here I will just write compressed, okay, and then we can take the next case, okay. The next case is, we can take it here, okay. Now this is the graph of y equal to modulus function x. If I have to make graph of negative of modulus function x, then it's going to be like this, okay. The reflection of this around the x-axis. Now this is y equal, negative of modulus function x. Now, if I have to make graph for y equal to 2 times negative 2 of modulus function x, then see here. Now, what would happen? See here. Now, if you look at the slope is negative, okay? So the y will change twice as faster, but in the opposite direction, okay? In the opposite direction. So here, if I put here -1, then y will get -1, y will get, what will happen to y? If I put here -1, y is going to get -1. See here, -1, -2, -1. Okay, so this will become 1, -2. So x -1, let's take +1 first. +1 -2. Okay, so this is going to be the case. Then 2 -4, 2 -4, this is going to be the case. 4 see here, 4, it's going to be 6. So you can see it's going to get compressed. So same on the same here. Okay, if you will do it for y equal to -3 times absolute value function x, then see here, for 1 it's going to be -3, right? So it's going to be here. Okay, so it will get more narrower. Okay, so as the value of slope increases, there will be the compression. Okay, so when you increases the value of a, there will be compression. And as the value of slope decreases, a decreases, then what will happen? It will get stretched. It's the opposite. If you go from 2 times modulus function x to 1 times modulus function x, 2 times was this, 1 times was this, so it was stretched. Okay, it got stretched. Okay, so this is the case. Okay, I hope this is clear to you. Now, slope is very important. Now, the why slope is very important, because if you know the concept of slope, then you do not need to make the coordinate table, right? You don't need to fill in the value of x, get the value of y. You can just calculate everything in your mind. Why? Because you know the slope 2 times. So if slope is 2 times, you put x1, you will get y2. If you put x3, you will get y6, right? So that's how it works. Okay, so this analysis is very important. You just go through it one more time, pause it, watch this video several times, pause it. If you do not understand, watch it. Okay, and I'm sure at one stage you will understand what I've said. Okay, so I will end this session here. When I will see you again in the next session, then we are going to use absolute value functions using transformation, where we are going to use all the concept, all the things that we have analyzed, we are going to implement there. Okay, so that's it for today, and thank you very much. Have a great time. Bye bye.